All right, so our review will probably be short today. Hopefully it'll be shorter today. And then when we finish, you guys can do some makeup work if you need to. That'd be a great time to do it. Tomorrow, yeah, tomorrow you do have a test. We will not Zoom. We will not Zoom. Your attendance will come from your test. Guys, you need to work on days that you're not here. Period. We're at the very end. It's like 2 or 3 from the back. It's like we're almost done. You got it?
Do you have notes from any other, like, permission?
There might be some in my, I don't know what she wrote on. Miss Walter did it yesterday, so I will check and see. Okay. If not, we'll get you a copy from somewhere. Okay. All right. So we're going to start. Remember that you can use your calculators on this. That is perfectly fine. I'm going to make sure that mine is in Stat Diagnostics on. So make sure that that on box is highlighted and then we're good to go. The first one says determine the correlation coefficient. So we're going to go into Stat and edit, and we're going to type our stuff in. I'm going to pick my calculator up so it's easier for me. If you do not have a calculator, you may want to get one so that you can follow along. Guys and girls, please don't talk. There are calculators over there. If you want to follow along, that would be amazing. Please. Okay, giving everybody in class a few minutes to get their calculators. You're going to be doing this exact same thing tomorrow. Okay. So what? Okay, first of all, make sure you go into mode. Mode. I went to mode. And this Stat Diagnostics, make sure on is blocked. You just hit enter on top of it. Stat Diagnostics, yep. Uh-huh. Go.
I already went into on.
Hit enter. Uh-huh. All right, so then go to a regular screen. And you're going to go to Stat and enter on edit. Oh my gosh, you should know because I taught this last week. Yes. You've been putting it in. Stat.
No, I know that. How do you get to that now?
You didn't know.
I
was just telling you.
You sure? Is everybody else okay?
How much do these cost?
$150.
Each?
Yeah. You can get cheaper ones. Those are just the most advanced ones. All right. So, sorry. Stat, edit, and put your list in. Remember, the top is always X. The bottom is always Y. If it's side by side, the left is X and the right is Y. Okay, get another one. You're going to go back to Stat, over to Calc, and down to number 4. Your correlation coefficient is whatever R is, and in this case, R is 1. It says describe the relationship between the number of minutes worked and the number of words typed. The relationship is going to be, is it positive or negative? Is it strong or weak? So R equals 1 is positive. It's okay. Guys, I need y'all to stop having random conversations. Stop. And it's strong because it's close to 1. And again, it is perfect because it is 1. But the closer it is to 1, the stronger it is. All right, bringing my calculator back up. It says to find a linear model to represent it. Your linear model is on your calculator. So you see on your screen, it says y equals ax plus b. You're going to plug in for a and b. And it tells you what a and b is. So you're going to do y equals, it says a is 32. Then we have an x plus b is 0. But if it's multiple choice, sorry, it will not have the 0. It'll just be 32x.
pencil on E or is it paper?
Nope. Paper and pencil. But it's multiple choice, so they're gonna take their test and then they'll upload their multiple choice answers in. All right. It says predict the number of words typed in 35 minutes. So if we look at our equation and we look back at our chart, Y is the words typed, X is the number of minutes. So for the next two problems, you're gonna use that equation. So we're gonna write it down. And this says 35 minutes. So is that going to go in for X or is it going to go in for Y? X, because X is the number of minutes. So we're just going to plug it in. 32 times 35. Put it in your calculator. And we get 1120. That's your answer. You're going to do the same equation again, but this time it says 300 words. Where do we put the words at? X or Y? Y. So we're going to have 300 equals 32X. I'm going to rewrite it over here. Just rewriting it, I didn't do anything. How do we solve for X? How do we get rid of the 32? Divide by 32. You can put that in your calculator, 300 divide 32. And that's it. So use that equation, know which one you're plugging into. Typically number 4 you will get right and number 5 people get wrong. Okay, just because they have to plug in for Y and then they get confused about how to solve it. It's really simple. New chart, same exact thing. Okay, use the following for 6 through 10. The following table gives the number of tons of solid waste that's generated each year. Determine the correlation coefficient. So we're looking for R. If you don't have your stat diagnostics on, the R will not show up. So that's what you turn it on for, okay? So I'm gonna go back to stat and edit. And Ms. Walter said yesterday she likes to clear hers. Don't delete it, clear it. Go up to L2 and actually hit clear. Or go up to L1, hit clear, and then hit enter, and it will make it actually clear. Okay, do not hit delete. So go up to L1, hit clear, all the way up to L1, hit clear, and hit enter. Is everybody good? I'm gonna put my new chart in, 1990, 1991. L2. And again, just make sure that you check once you finish that you put in the correct numbers. Sometimes I mess it up, so don't feel bad if you mess it up. And you only have to change that number. So 90, 91, 92, 93, 94, 19358, 19484, 2293, 21499, 23561. To get the line technically, but when they give you the chart, unless they specify, you want to use the whole thing. Because these are not perfect points on the line. What I told you was perfect points that were on the line. These are just data points. We're trying to find something that gets close to it. Okay. All right, we're going to go to stat again, over to calc, and down to number 4. Hit enter a bunch of times. And then what's our correlation coefficient, or our R? I'm gonna do a couple decimal places, 0.9445. When you're comparing, make sure you do a couple decimal places, okay? Don't just put 0.9, because some of them could be 0.91, some of them could be 0.93. We wanna make sure that we have a couple decimal places. So what is this? Remember, your relationship is either gonna be positive or negative, strong or weak. So is this one positive or negative? It is positive because the number is positive. Is it strong or weak? strong. Think about it this way. Think about it as a percentage. Like if I move my decimal back 2 places, that would be 94%. Is that a strong grade to get, or is that a weak grade? It's a strong. 94 is an A, right? So maybe think about it like that if you're getting a little bit confused with a strong versus weak. All right. Number 8 says the same thing, model to represent the data. This one is a really nasty one, but you do the same thing. Remember, you can use your calculator, so it's not a huge deal. Yeah, strong positive. All right, so y equals ax plus b. We're going to plug in for a and b, and those are on your calculator. So y equals, a is 1042.1. Put your x, don't forget that x, a plus. And then you can put a plus or you can put a minus here, but it is a negative huge number, 2055.024.2. And yes, I would write all of it. What did x represent? Read it one more time. Here's your chart. Look at your chart. What did x represent? Yep. Remember, it's always in order, x, y. So on this chart, x is on top, y is on bottom. On a chart like this, x is to the left, y is to the right. Okay, so x is the year, and y is the tons of waste, or just waste. So x is the year, and y is the waste. So this one says, predict the amount of waste in 1996. Is that going to go in for x, or is it going to go in for y? X, because it's a year. So y equals 1042.1, put your parentheses, 1996 plus negative 2055.024.2. We plug that into our calculator, 1042.1, parentheses, 1996 plus negative 2055.024.2. And we get 25007.4. For number 10, you're going to use the same equation, but this time it gives you 18,000 tons of waste. So where is that going to go? X or Y? If X is the year and Y is the waste, where is 18,000 going to go? In the Y. So we're going to write it down. 18,000 equals 1042.1. We didn't do anything with X, so you leave that alone. Plus negative 2055.024.2. Try to make it a little bit bigger so you guys can see it. All right. Look at this equation. What are we solving for? It's a normal equation. Don't freak out because it's got big numbers or decimals. What are we solving for? Is there a y in that equation? What's the only letter in that equation? X. So we're solving for x. What's on the same side but not with it? How do I get rid of a negative? Add it. So I'm going to add to both sides. I don't care. I'm going to write it all down. You do whatever. It's your notes. Okay. So we're going to do 18,000 plus 2055024.2. And we get a big, huge number, and that's okay. So this canceled out. We got 2073024.2 is equal to that 1042.1x. How do I get x by itself? Divide by 1042. You guys know how to solve it. Don't freak out because it's big numbers. You have your calculator. So these will cancel out. I'm going to divide this by the 1042.1. And I'm going to get 1989.27. So what year was it? 1989. So again, don't freak out when you have to solve. Number 10, the other one, it was like number 5 or whatever. Those are the ones that were most missed on the test because you won't take the time to solve it. You see big numbers and you're just like, whatever. Okay, make sure that you do that. You know how to solve. All right. The next one's same exact thing. Same exact thing. So we're going to change our stat. 1992, 93, 94, 95, 96, 97. I'm going to pick it up so I can put the other ones in. 703,000. 808,000. 929. 1060. And then you'll see that it changes mine to E6. That's okay. That's just scientific notation. You put it in right. As long as it says E6, we're good to go. Did you just let somebody in? Oh, I saw him. No, I saw hers, like Savannah. She popped up. I don't know what's going on there. All right. We're going to go to stat, calc, linear regression. Hit enter a bunch of times. What is our R? Yeah, and I'm going to do 3 or 4 decimal places. Not a big deal. When it matters is when you compare, okay? When it matters is when you compare. Positive, negative, strong or weak? Positive and strong. Good. Find a linear model to represent this data. The linear model is right there. Again, it's a nasty equation. We didn't pick these. Somebody else made these notes, so we're sorry. 131,057.14x. You don't have to put the 29 if you don't want to. It's fine. And then we have a minus. You can put a plus negative. That's fine. 26038.2304.8. And again, yes, it's pretty nasty, but we can handle it. Looking at our chart, what did X represent? The year. What did Y represent? The number of students homeschooled. Just the number, that's all that matters. So now you're done with the chart. You don't even need it anymore. It says predict the number of students homeschooled in the year 2000. So where are we plugging in 2000? For X, perfect. 131,057.14. When you get to X, put the 2000 in parentheses. Minus 26038.2304.8. And then you're just going to type that in your calculator. I'm going to slide it up so you guys can see it. 131,057.14 times 2000 minus 260382304.8. Gosh, that's ridiculous. No, they better not be. I had to check it. It's on. You could probably see it. They cannot see it yet. It's on the image. And we get 1731975.2. If I can remember correctly, they are easy ones because they're multiple choice. All right. So then we're going to look at predict the year for 500,000 students. 500,000 students. That's going to go in for our Y. So 500,000 is going to start our equation. Make sure you put enough zeros. And then those big long decimals. And then the same way we solve the other one. Get rid of the number that's not with X. What? I can't, we made it a couple years ago. But I think they're easy equations. They're not, if they're decimals, it's only like 4. Yeah, no, we don't try to do that. All right, so we're going to solve for X, what's on the same side but not with it, this negative 260, blah, blah, blah. So to get rid of it, we're going to add it. So that side will cancel out. We're going to add it to this side. $500,000 plus 260382304.8 gives you 260882304.8 equal to 131,057.14x. Again, don't stress out. It's the same work. You're using your calculator. So to get x by itself, we're going to divide by the 131,057.14. So we're going to divide 131,057.14. And we get x equals 1990.59. So what year? 1990. That's it.
So I didn't have to do the work, I just put down what you did in that file.
That's okay. As long as you do that stuff. And then actually do your test tomorrow.
I'm still working on the unit test.
It's okay. What I need you to do, make sure you do this test. Guys, don't get zeros on tests. They're 60% of your grade.
Yeah, I'm trying to get my grade up here.
All right, so that's goal 1. Josh, pick your head up and take notes, please. Thank you. All right, use the following for 16 through 19. David and Fred each throw a baseball into the air. This is what we did yesterday in class. The velocity of David's ball is given by this equation, negative 32t plus 50, where v is in feet per second and t is in seconds. The velocity of Fred's ball is in the table. Determine a function to represent the velocity of Fred's ball. So how do we get a function from this? We've been doing it all day. So 0.2, 0.4, 0.6, 0.8, 1.0, 38.6, 32.2. This is what takes longest, is just putting it into your calculator. And then we're going to do stat calc and our linear regression. So Fred's, if we look at our equation, y equals ax plus b, we're going to plug in for a and b. Don't forget that. So y equals, our a was negative 32. Make sure you put your x, your b is 45, plus 45. That's all you do for 16. Okay, it just wants Fred's equation. All right. Which ball had the higher starting velocity? Which number represents where you start? The one with X or the one that's not with X? So we're going to look at 45 and 50. Which one was the highest? David's. What do the slopes of each of these equations tell us? What's happening? They're both the same, right?
How fast the ball flies.
And we can say speed of decrease is what I'm gonna go. How fast each is falling is perfectly fine. And the reason that's good is because you said fall, so you know it's going down. Okay. All right. If each person's ball had been in the air for 0.5 seconds, who has the fastest velocity? So all of this is saying is take this 0.5 and plug it in for X because X or T was your seconds, okay? So here's what we got. We're gonna start with David. His was negative 32T plus 50. So what we're gonna do is plug in that 0.5. And we're gonna see what we get. This is exactly what you did in your homework yesterday. Those of you that did it. Negative 32 times 0.5 plus 50 gives us 34. Right. Then we have to do Fred. We said that Fred was negative 32, and we put X, you can put T, it doesn't matter, plus 45. So we're gonna plug in that 0.5. Yeah, I'll put 0.5. And I got 29. So who has the faster velocity? That's all you're doing. And that's all you did in your homework yesterday. Okay. These are EOC questions. I'm telling you right now, you're going to have these on the EOC. End of course. Mm-hmm. All right, so now they give you a graph and they give you a chart. Write an equation that describes data set 1. That's this one. And it tells you that in your notes. Data set number 1 is displayed in the graph. So this one is data set number 1. This is data set number 2. So how do we write an equation for this line? Remember, we do where we start and our rise and our run, right? We need our slope and our intercept. So here's our y-intercept. So we start at negative 3. And then here's another good point at 1. What was our rise and our run? I need your help. What was our rise and our run? Thank you. And this is going up, so it's positive. We're just a positive 3. So here's your slope. Y equals 3x. And then where did we start? Negative 3. There's your equation. We did this on the last couple tests, so you should know how to do this. Number 21 is going to ask me to write an equation for this one, but I'm going to stay here for just a minute so that you guys can see your chart. We're going to put it into stat. Negative 1, 1, 3. How about I do it right? Negative 1, 1, 3, 5. Negative 1, 7, 15, and 23. These are more the type of numbers that you're going to get on your test. Go over to calc linear regression. And then there's our equation. See, it's a nice, neat little equation. All right. All right, from the page before, I just wanted to recopy that down. Data set number 1 is 3x minus 3. We just did data set 2, and we got a 4 and a 3. Write an equation, describe data set 2. That's what we just did. All right, 22 says a greater rate of change is the same thing as slope. So which one has a bigger slope, 3 or 4? Data set 2. And it's going to be multiple choice, and it's going to say data number 2 or data set number 2. What is the difference in the y-intercepts of the 2 data sets? 6. Negative 3 minus 3 is negative 6. So your y-intercept's negative 3 and 3. We want a difference, so we're going to subtract them, and we get negative 6. Okay. Use the following for the child X as displayed in the table. This is almost the exact question that you're going to see tomorrow. The predicted height of an average child is given by the function. So this is the predicted. And then this chart is child X. Okay. So we're going to go ahead and make our equation. We're going to go into stat and edit. 6, 12, and 18. 23, 25.5, and 28. Edit, get that one out. So stat, calc, linear regression. It says, write an equation to describe the growth rate for child X. That's what we just did. Y equals, you don't have to put all these, 0.416, then your X plus 20.5. 25 is kind of a trick question. Was child X shorter or longer than the average child? That's this one, average child. When he was born, and how do you know? Think about it. What does this 0.3 represent? What is that number? The what? The rate of change. That's how fast they're growing. What is this number? How they started. So this is the start, and this is the start. So they are the same height. Now, what's the difference? Yeah, the rate of change. So child X actually grew faster than predicted. You guys see that? That's it. All right. That's the test in a nutshell. That's pretty much it. Got it?
Besides the part where you gotta go through and do the things.
The Ys.
7, 7,
The Y, yeah. They won't be like that on the test. All right. I'm going to stop sharing, stop recording.